Hey guys, as you can notice, I'm not here today. I had to go to the doctor. Has nothing to do with the letter that you got yesterday. I just have to go get a physical checkup. When you get as old as I am, you have to start doing these things periodically, so don't worry. I'll be back on Monday. But I do want to give you some notes on the problems that you're going to be doing today on your worksheet. Remember yesterday we talked about the sine and cosine graphs, and we just talked about the basic graphs for these. If you'll remember, the middle was always 0 for us. We always started at 0 yesterday. And so I'd given you this sheet for notes, so you need to get that out because we're going to go over that, and I'm actually going to work example 3 on the back of that sheet. But what I want to do is I want to add to the bottom of your notes here where it says horizontal shifts, because what we're going to do today is we're going to shift these graphs to the left or to the right. So they're not necessarily going to start at 0 every time now. Now the middle of the graphs will still be 0, but our starting point will not always be 0. So what you do for your horizontal shifts here, I went ahead and it's written down on your sheet. It says you take x minus c equal to 0 and you solve it. Now what a horizontal shift does is it moves the graph left or right. Okay, that's what a horizontal shift does. So in the problems now, whenever you have your standard form, right, let's say the standard form for sine, it's a sine, and then we had b, and then right after that we had this x minus c part. Okay, this is the part right here, this x minus c, that you're going to set equal to 0 and solve. So basically whatever comes after the sine and this b here, what's in parentheses here with x, we're going to set that equal to 0 and solve it, and that's going to tell us our starting point. Whereas before we always started at 0, now we may not do that. So let's flip over to the back and let's take a look at example 3 here. We did examples 1 and 2 yesterday in class, all right, and then you practice some of those. So let's take a look at example 3 here. So we've got -3 sine 2x minus 180. So to find the amplitude, we do the same thing. We take the absolute value of a. So we take the absolute value of -3, which is positive 3. To find the period, we do the same thing. We take 360 and we divide it by b, and b in this case is 2. Now I know that that 2 is inside the parentheses, but that just means b has been distributed. So it doesn't matter whether it's inside or outside, it's the number in front of x. So we're going to divide that by 2 and we get 180. Now here's where the difference comes in, is our starting point. This starting point is also what's called the horizontal shift. That means the graph is going to shift either to the left or to the right. And to find that, it's what we just talked about on the front. You take what's in parentheses here and we set that equal to 0 and solve it. So I'm going to take 2x minus 180 and I'm going to set that equal to 0 and I'm going to solve it. So we add 180 to both sides and we get 2x equals 180, and we divide by 2 and we get x equals 90. That 90 is now my new starting point. So I'm no longer starting at 0 today. Now to find the end, we do the same thing. We take the start and we add the period to it. So 90 plus 180 is 270. And for our increments, we still take the period and we divide it by 4. And 180 divided by 4 is going to give me 45. Okay? Now, we're going to do the same exact things we did in yesterday's. We're going to put our start there, which is 90. We're going to put our end here, which is 270. And now we're going to count with our increments of 45 to get the rest of our x values. So 90 plus 45 gives me 135. 135 plus 45 gives me 180. 180 plus 45 is 225. And 225 plus 45 is 270. And then if you'll remember, to get your y values, you type these numbers into your calculator here replacing x. So we'll put in a 90 for x, a 135, and so on, and we'll get out our y values. Now, you need to be careful when you're typing these in the calculator, and just to make sure, if I'm typing in the 90, I'm going to put in -3 into my calculator, sign, and then that parenthesis pops up. Now, the way I would type it in is to do 2 times 90, then minus 180, like that. Okay, and then you can just change out the 90 here with 135, 180, 225, and 270. All right, so when you type all of that in, the answers that you should come up with are, let's see, all right, these are the answers you should come up with. 0, -3, 0, +3, and 0. If you type all those into your calculator, that's what you're going to get. And so you end up with those, and then we plot those points. Now remember we talked about yesterday of putting this information on the graph. Okay. My increments are 45, so I think what I'm going to do is I'm going to let my graph go by 45s. So this is 0 here. I'm going to let this first mark be 45. So my next mark is going to be 90. And then I go 135, 180, 225, and 270. And I know that's really small in there, so if you want to space it out more, you're certainly welcome to do that. My sinusoidal is still here in the middle. That's not changing today. The middle of your graph will always be on the x-axis still. So now we just graph it. So we're at 90, 0, 135, -3, 180, 0, 225, +3, and 270, 0, and we sketch it. Okay, now you'll notice that this graph does go the opposite way than our regular sine curve on the front, or it goes the opposite way from example 1. Here was example 1, okay, and the reason that it goes the opposite way is because this was a -3 to start with, not a +3, so it's been reflected. So this is how you do horizontal shifts. So the only change for what you're going to be doing today is going to be this starting point. This right here, your starting point, the way you find that will be different. It's not going to be 0 every time today. What you do is you take what's in parentheses, set it equal to 0, and solve it, and that will tell you where to start. And then everything else is exactly like you did yesterday. So the sub's going to give you the worksheet. You need to do that worksheet, complete it, and then turn it in when you're finished. And all it is exactly like this example here, working problems, and you should have plenty of time to get that done. You can work together, I don't mind that, but turn this in. This will count as a daily work grade for you, so I know some of you have been wanting some grades in that category to help you out a little bit, so this is a great way to help you out because you have the whole class to work on it. So we'll see you guys on Monday. Have a great weekend.